Hey guys, good morning. Hey Katya, how you guys doing? I guess it's just you for now. Uh, um. All right. Well, I guess I'll start with you. Did you have any questions on the last two problems for the CYU? I know I left you guys to try them on your own. Was there anything that you wanted to go over? Maybe talk about before we move on. I'm good. You know, it's a lot of work still. There's a lot of emails every day. I think I'm getting like 50 to 60 emails a day, which is way more than the usual. So it's kind of hard to keep track of everything, but I'm trying, doing what I can. Yeah, okay, let's do D. Let's do it. Okay, so, um, hey Dave, what's going on, man? How you doing? How you guys feeling? You guys feeling stressed, overwhelmed with all of this? Are your teachers giving you like a fair amount of work, or do you feel like you're getting too much? I'm really curious. I want to know. All right. Well, I guess we'll talk about it as we go. Okay, so let's take a look at D. All right, so D has some information here. So it says that Chantel wants to make a down payment of 10% on a condominium with a value of $150,000. Stressful, yeah, I can imagine. Um, so what that means here is that she wants to purchase something that's worth 150,000. Okay, this is what she wants to buy, but she wants to make a down payment of 10%. So she basically needs to have that money like already in her account so that then she can make that down payment. So we need to find out. Well, let's read the rest. So for how many quarters would Chantal need to contribute $450 to her credit union account to have enough money for the down payment on the house? So just to recap, this is the problem where this lady was she was depositing $450 into her account, and the account itself was also collecting interest. So there was some compound interest collected quarterly. Okay, so the condition now is that she wants to buy a condo. She's still going to continue to contribute $450 every month, but she has a goal now, right? She there's a certain amount that she wants to get to because she wants to make a down payment. So first, we look to see what the down payment of a condominium that's worth 150,000 would be. So first, multiply this times the 10%. So remember, 10%, you move the decimal space 2, so it becomes 0.10. Okay, so if we multiply that by 0.10, basically 10% would be 15,000. Okay, so her goal is to work up to 15,000. All right, so that's what she needs to get. Okay, that's what she wants to get. But the question is, how many quarters would Chantel need to contribute $450 to her credit union to have enough money for the down payment on the house? Okay, so we got to go back because some of the information we've already worked through it. So you remember here in part A when we worked through to see how much you would have to after year 1, year 2, and year 5. Well, we can pick up here, right? Because after 5 years, there was a certain amount of money that she had. So going back to that, where was that, part A? Okay, so here, right, we looked at this, and so she would have, after 5 years, $9,738. Okay, all right, so that's kind of where our starting point is. So after 5 years, what was it? 97.38. Wait, 96 cents. Okay. But obviously, remember that the goal is to get to 15,000. So she's still short, right? So after 5 years, that's what, 60 months? Okay. All right. Well, let's see what would happen. Remember that she is getting quarterly deposits. I'm sorry. So yeah, it's quarterly deposits of $450. So that means every 3 months she's depositing $450, and then there is a 1.2% compound quarterly rate. I'm sorry, the annual rate is 1.2. So then quarterly, it's a different amount. So we can basically keep going on this recursive formula that we looked at right here. Okay, so here in this red bubble, right, this is the process that we were going through to find out how much she would have after each quarter. Okay, so if we continue this, notice what it was that we were multiplying by, right? Whatever amount that she had, we would multiply it by 1.003, and then we would add 450. So remember that if it's a quarter, that's a total of 3 months. So we can keep track of that to see how much longer it's going to take her to get to the 15,000. All right. So in this case, because this is what she currently has, the 97.38 with 96 cents. Well, it's still adding interest, right? So she's kept the money in the account. It's going to be compounding and multiplying times the value of 1.003. And then she's still adding $450, right? So this is after 5 years. So if it's another quarter, then that's another 3 months. So now we can consider this at 63 months. Okay. And so then we just have to go through the calculations. So 97.38.96 times 1.003. Okay. Oh, wait. Oh, I messed up. 97.38.96 times. Okay. So it was 97.68 with 18 cents, and then she deposits her own 450, right? So then after those 3 months, okay, she's at 10,218 and 18 cents. Okay, so at least she's crossed over into the 10,000 mark. So we'd have to keep doing this until we get to the 15,000. All right. So now 66 months, right? Another 3 months have passed. Right. So now she gets a balance. She has a starting balance of 10,218 with 18 cents. And then we multiply again by the same rate, the quarterly rate, which is 0.003, right? So 1.003 is what we multiply by, and then she deposits her own 450. Okay. So it's the same process. It's the same repeated process that you keep going until you get to the 15,000. And then once you get to 15,000, once you cross that point, then you can then say that's how long it's going to take her to reach her goal. Right? So it's kind of a tedious process to have to do this over and over, but the more money she has in her initial, this part right here, the faster it grows, right? Because 100 is larger than 0.3% of 9,700. Okay, so that was after another quarter had passed, right? Another 3 months. So now another 3 months. Now let's go 69 months. Okay, starting at 11,148 with 83 cents. Multiply times that quarterly interest that you're earning. Then you add your 450. Okay, so 450. Okay, so 11,632 and 28 cents. Okay. All right, now let's go 72 months. Right, so now this is basically at 6 years now, right? So the full quarter has passed, the full year has passed, I'm sorry. So it's starting at 11,632, 28 cents times 1.003 plus 450. So now she's crossed over into 12,117 and 18 cents. Okay. All right. So you keep going, you keep going, you keep going, you keep going. And that's the idea. Okay. So if you were to do this correctly, right? You do it for 75 months, you do it for 78 months, you do it for 81 months, do it for 84 months, right? And so it's going to take a while, right? So but you understand that's the process. That's the process to get there. After the 6 years, she's at 12,000, so I probably anticipate maybe like another year and a half, and then she'll probably get to about 15,000. Okay, so the correct answer is it should take 31 quarters. Right, 31 quarters means, well, 31 times 4. So 124 quarters. Okay, so if you're talking about, that's the amount of months, right? That's 124 months. Divide that by wait a second. It's every 3 months. Wait. I don't know if I'm supposed to multiply by 3. I think it's by 3 actually. Okay. Yeah. So I was over counting actually. So 31 quarters. You don't multiply by 4 actually. You multiply by 3. It's kind of a strange thing, but eventually it's essentially 93 months. Okay. So really we're not too far from it, right? If we stopped at 72, we would have had to kept going 87, 90, 93, right? And right around here, when we get to that 93 months, that's when you would see that she would have crossed over above 15,000. Okay, so 93 months, divide that by 12, right? The amount of months in a year, and you would get 7.75 years. Okay, so I'm just cutting the problem short because it just takes way too long to go through the whole thing. But this is the idea, right? It's a recursive process. Okay, it's recursive because you utilize what you ended with, right? Your final balance at the end of a quarter to then start with that initial amount. Okay, then whatever you end with, then you start with that initial amount. Whatever you end with again, right? You start with that as your initial amount. Okay, so it just keeps, you keep adding, you keep multiplying by the same thing, but the initial keeps changing, right? Because at the end of every 3 months, you have a new balance. Okay. Does that help a little bit answer that question? Okay, as long as you know the process on how to get there. That's the important part. Okay, the recursive stuff just takes a long time to get through. Okay. All right. What about E? Were there questions on that one? Did you want to see E as well? Should we do it? All right, let's just do it. Okay, so for E, Chantal opened her credit union. So when she opened her credit union account, her parents also purchased a 5-year CD account for $5,000, earning 7% compounded monthly. Right? If she combines the future value of the CD with her credit union account, will she have enough for the 10% down payment for the condominium in 5 years? Okay, so she still has the goal of the 15,000. Okay, will she be able to get there with the CD plus the other account, right? The credit union, right? Because this is the account where she kept putting $450 in there, and it had an interest rate of 1.2%. Okay, so the CD, okay, is what we need to calculate, because it's saying after 5 years. Well, we already know how much money she had after 5 years in the other account. So if we go there, right, after 5 years, she had 9,738. Okay, so let's see if at the end, 9738. Okay, we just need to find out how much is going to be in that CD account. Is it going to make up the difference, right? Is it going to make up the difference to be able to get her to 15,000? So for the CD account, pretty easy. This one is nice and easy because she's not adding an additional amount every month. So it's the 5,000, and because it's a CD account, you can't make additional deposits into an account like that. Okay, so it's already frozen. So we get to use the final value formula, which is initial times 1 plus the rate over the number of compounding times in a year to the n times t. Okay, so this one's easy because you just plug everything in. All right, so initial value then, it's the 5,000. Okay, times 1 plus the rate. The rate is 7%, so that converts to 0.07. Okay, because it's compounded monthly, n has to be 12, right? 12 times in a year. All right, so then we replace n with 12 again, and then this time times the number of years, which is 5. Okay, so 5 years. All right, so let's clean this up a little bit. Start from the inside of the parentheses. Okay, we have 0.07 divided by 12. Okay, I don't want to round that number. I'm going to just keep it working in the calculator. So then to that, I would first add 1. Okay, then remember that the power takes priority before you multiply by 500. Okay, so we take this because it's 12 times 5, then that's actually the power of just 60. Okay, so then take this to the 60th power. Oh, I messed up. Sorry, I put 600. Okay, 0.07 divided by 12 plus 1 to the 60th power, and then times 5,000. Okay, so this gives her $7,088.13. We'll round it up. Okay, so this is what she got from her CD account right here. So we can take that, we can add it to the amount she was going to get from the other credit union, which is $97.38 with 96 cents. And let's see if she gets enough for the down payment. So all right, yeah, and so she gets there, right? She's going to end up with 16,827 with 9 cents. Okay, so so let's see. What can we summarize? Yeah. So from or Chantal earns $16,827.09 from both investments after 5 years. Okay, she has enough for the $15,000 down payment. Okay, so that's pretty much it for part D. Okay, so that's an easy one. It's a little bit it's not harder necessarily, it's more straightforward, right? You can just use the formula, versus the other one you can't use the formula because you're, in addition to the compounding, then you're adding more money into the account, so it has to be done like recursively. Okay, so some problems you can do the formula, other ones you have to approach them with the recursive process. Okay. All right, so that pretty much takes us to the end of investigation 2. Okay, so we're done with simple interest and we're done with compound interest. So we're gonna go ahead and we're gonna start the next investigation, investigation 3. So investigation 3 is all about investing strategies and tools. Okay, so essentially it is building on the compound and the simple interest. So a little bit of strategies and techniques in terms of, investing. Okay, so let me go ahead and flip over to the next page. All right, so this is all about, let me give you a little title up here. So it's Unit 4, Lesson 1, Investigation 3. This is all about investment strategies. So you can go ahead and start a new section in your notes. Okay. So we'll probably get to, we'll definitely try to get through at least the first problem today, and then we'll see if we can start number 2. All right. So it kind of jumps in here with the first problem, giving us a scenario, right, where when Lucy was born on August 1st, her parents decided to save money each year for her post-secondary education, right? So basically a college savings account. That day, they opened a savings account with $400 and then deposited $600 every August 1st. Okay, so think about what's happening here. When she was born, it was August 1st. And then every August 1st, right, they're depositing $600. Okay, but the day that they opened the account, there was $400. Okay, so $400 to start the account and then $600 every year, right? Because every August 1st. So it's a 1 full year, 365 days after that they invest the other amount. Okay, for the next 18 years, right? So they're doing this for 18 years. Okay, assume that each year the deposit is made at the end of the compounding year. Okay, so basically that means that they put money in, let's say August 1st. They let that compound, the interest compounds throughout the entire year, and then the next year, August 1st, then they inject a little bit more money. Okay, so then you have a new starting amount the next year on August 1st. Okay, so I'll make a diagram about that. We'll keep track of what's going on. Okay. Now, if the bank provides an annual percentage yield, okay, this is what we know, right? It's a percentage yield, so we know exactly how much money is going to be in the account at the end, right? So we don't have to use the final value formula, right? Because we're given the yield percentage. Okay, what will be the balance when Lucy turns 1, turns 2, and turns 3? Okay, so let's just give this a date, right? Let's just say August 1st of the year, let's say 2000. Okay, so we have August 1st of the year 2000. Okay, on that day, there's $400 that it gets put into the account. Okay. Then we want to take a look at what's going to happen August 1st of the year 2001. All right. Well, 2 things happen, right? There's going to be a deposit of $600, right? But the deposit takes place after all of the compounding has taken place throughout the year. Okay, so if the bank provides an annual percentage yield of 3.2%, what would the balance be when she turns 1? Okay, so this is when she was born. This is when she turns 1. Okay. So if I know that throughout the year it's going to yield 3.2%, I know that whatever I started with, then it's yielding 3.2% of that. Okay, so what I can do here to calculate that is say, well, I had the 400. Okay, I need something to multiply it by to tell me how much interest it was earned throughout the year. Okay, so I know that there's 400, so I need a 1, right? Because 400 times 1 keeps me at 400, plus whatever it's going to earn in interest for the whole year. So if they're telling me it's yielding 3.2%, I know that that's exactly how much interest I'm going to earn on that. So I turn 3.2% into a decimal, so that becomes 0.032. Okay. All right. So in black will be what the interest, the compounding is doing. So if we were to distribute here, you can see, well, the 400 times 1, that's the 400 that's in the account to begin with, right? But on top of that, right, you add what the interest is going to earn on those $400, right? So the 400 times the 0.032, that's 12.8, right? So plus 12.8. Okay, so we're looking at $412 with 80 cents. Okay, and then, right, what do her parents do? They add the 600 on top of it, right? So once the compounding has taken place, they inject $600 into the account. So now we're looking at $1,012 with 80 cents. Okay, so that's how much she has in the account after she turns 1. All right. Okay. Next one. Let's talk about year 2. Okay, when she turns 2. Now we're looking at what's going on August 1st, 2002. Okay, well, do you see that this is what she is going to start the year with, right? So we need to find out how much interest is going to be earned on the new balance, right? Now that the balance is $1,012.80, right? So we're looking at a recursive process, right? Because these people are not only earning interest from the bank, but then they're also investing in it additionally, right? So this is what creates that recursive process, is that it's not just interest being earned, it's money being invested as well, in addition to what's already there. Okay, so now that means this is the initial amount that we start with. Okay, so because we're trying to see what's going to happen at the end of the second year, right? When the first year ends, they end with $1,012, so that's what we start with. And then we're still going to multiply that by 1 plus 0.032, okay? Because it's saying that every year, right, it's an annual percentage yield of 3.2%. So you're yielding that every year no matter what. All right. So here's how the math works, right? You multiply by 1, that's $10,012.80. Oh, I forgot to put the 0.80 here. Okay, so that's the fixed amount that was in the account, and then on top of that, right, you're going to add whatever interest was earned in that 1 year period, right, the yield. So when you multiply this through 1012.8 times 0.032, okay, this year it earned $32 in interest with, we'll call it 41 cents. Okay, so you had your initial amount and all of the interest that you're earning for the 1 year. So let's go ahead and add it up. Okay, so then we are looking at finishing up the year from the interest, right? Just from the interest that was earned, right? Just that balance was 1045.21. 1045.21. Okay, but then what do her parents do? Right, they continue to invest, right? They add another $600 into the account. Okay, so then we're looking at 1,645 with 21 cents. Okay. Okay. So this is where she ends, right? At the end of year 2. And now year 3 starts, right? The third year. So now we want to see what is she going to end with when she turns 3. Okay, so now we're going to see what is that final amount on, what's going on? August 1st, 2003. Okay, so since she ended year 2 with 1645.21, then that's where she starts at the beginning of year 3. Okay, again, same product. Okay, because the 1 allows you to keep everything that's in your account, but on top of that, you're adding whatever you're going to get from the interest, right? It's the annual APY, right? That's your APY. It's the yield. Okay, so now we go ahead and distribute, multiply by 1. That's still 1645 with 21 cents. And now let's see how much interest she earns, right, on this new balance. So we should expect a higher amount of interest. So we have 1645 with 21 cents times 0.032. Let's call it 52.65. Okay, so she's earning. Okay, but remember that her parents, on top of that, they add the $600 every August 1st. So then what is she going to end with when the baby turns 3? We're looking at $22.97 and 86 cents. Okay, so there's year 2, year 1, and year 3. Okay, are there any questions on that so far? Right, so it's just a continuation of the compound. Not even compound, honestly, because we're told what the yield is going to be at the end of the year. So there's no point in us trying to find the there's no point in us using the final value formula for compound interest. When you're given an APY, you know that that's the amount of interest you're going to earn regardless. Okay, regardless. So you might as well simply turn it into a much more straightforward formula where you multiply by 1 plus your APY. Okay, the APY here is the amount of interest that you're earning. Therefore, you have to still multiply it. I'm sorry, you have to add 1 to that inside of the parentheses, because by multiplying by 1, that keeps you, right? That's the amount that you have in there. Then the other amount tells you how much interest you've earned. So then you add them together and it tells you your new amount, right? Your new amount plus whatever is being deposited into the account. Okay, does that make sense so far? Okay, if you're good, just shoot me a thumbs up on the chat. Okay. All right, so that was part A. Let's take a look at part B. I think we actually did part B already. So we kind of did it as we did part A. So for part B, it's asking how much interest does the college savings account earn at the end of the first year, at the end of the second year, at the end of the third year, right? How much interest was earned? Well, if you take a look at how we broke down the problem, right? This is why I like doing it times the product of 1 plus the interest rate, because then it breaks it up for me in terms of what is the starting amount and how much gets added to that account, right? How much does the interest contribute to my account? Well, the 400 is the 400 that was already sitting there. The new amount of money that comes in comes from multiplying times the interest rate, right? The APY. So we can see right there that in the first year, remember that 400 is what was there already. The interest earned is the 12.8, okay? Because the 600 is not interest that was earned. The 600, I'm sorry, is the amount that the parents put into the account, right? So in terms of just straight up how much interest is earned, well, for year 1, it was just, how did we find how much was earned? It was just 400 times the 0.032. right? It was just that part of the product that gave us the $12.80, right? So year one interest earned was $12.80, right? Year two, little different, okay, but still the same idea. With year two, it works out because the initial has changed now, right? Because this is how much money is now what you're starting the second year with. Okay, so you multiply that. Again, when you multiply it by 1, it just tells you how much is in the account. When you multiply times the APY, that tells you how much interest you've earned, right? So here we can see that's where we get the $32.41 from. It's from multiplying it times the yield percentage, okay? So same idea, right? With year two, except that you just didn't start the year with $400. This time you started with $1,012 with 80 cents. But you're still multiplying it times the same APY. Okay? But this time, because you obviously have a much larger amount, 3.2% of 1,000 is much larger than 3.2% of 400. So then this time, this allows you to earn $32.41, right? So you just earn more money in interest because you have a larger amount in the bank to begin with. And then finally, year three, you look to see with what you started the year with, right? You started the year with the $16,045, right? Thanks to all the contributions already, the $600 that were being added to the account year after year. And you find how much interest was earned right here, right? When you multiply times the APY. Okay, so to simplify and summarize that, the $16,045 with 21 cents, that's what you multiplied times 0.032. And then you ended up earning $52.65 in interest. Okay, so you see, the more money you have, the more money you earn, right? So more money, less problems. No, I'm kidding. More money, more problems. But this is where when people talk about investing, they always say like, oh well, it's never too late to start investing or never too early, no matter how little you have. True, right? It is true that even if you do have just a couple $100s to invest, maybe the first year, right? But then you keep adding a little bit more money to it year after year, right? You're putting money in, and then the money is working for you, right? Because as you get to these larger amounts, right, even though you're still multiplying it times the same interest rate year after year, right, look at how it changes and how much money you're earning by doing nothing, really, just by keeping it in a savings account. Okay, so when it comes to investing is basically another word for let the money do the work for you, right? Instead of you going out and actually working, like punching in, doing a job for a couple hours, getting paid, you put your money into an account where then the interest rate starts to make money for you. Over the course of 20 years, 30 years, right? You use it for retirement. You have a lot more money in that account than if you just would have saved it and put it in a different account where you don't earn any interest on it. Okay? So I highly recommend, right? Even if you just start with like a little part-time job, you open up an account where you can invest a little bit and then just add a little bit, add a couple hundred, maybe $100 in there every month. And then over time, you're going to start to see some long-term effects. Okay. All right. Okay, let's keep going now. So they want us to, for part C, to use let me go back up to the problem. It says use the word now to represent the savings balance in any given year. Okay, write the recursive formula using the words now and next. Okay, to show how to compute the balance at the end of the next year. What is the starting value of the account? Okay, well, let's break this down. So we have now, we have next, and we want to be able to write a formula that tells us what the balance will be at the end of the next year. Okay, so for part C here. Okay, so if we starting with an initial amount, Okay, again, it goes back to this particular scenario. Starting with the initial amount, we start with an initial amount of $400. Okay, that's how much money was put into the account on the day of the birth of the girl. Okay, now based off of that, we can then build the recursive formula, right? Because you can't have a recursive formula unless you have something to start with. Okay, because it has to be with what you start, then it builds onto the next. Okay, so in order for us to know what we're going to get next year, right? So next, right? What was the traditional, or what was that process? What would we do? Okay, we would take the amount of money we had now, right? And we would have to multiply that amount, right? So think of this scenario, right? Now was the $400, right? We started with $400. What did we have to multiply it by? And what did we multiply by every single time? It was by this right here, the 1 plus 0.032. If we simplify that, we can just add it together and leave it as 1.032, right? So whatever money we had now, we multiply it by 1.032, okay? And then something else had to happen, right? Because that wouldn't necessarily give us what we were going to start with the next year, okay? That would just tell us how much interest we earned on top of the balance, right? So that would give us how much money the interest is giving us plus what we have. That's where we're at, right? So basically it gives us this. But then what did we need to do next? We would still have to add $600 to it, and that would give us next year. Okay, so whatever we have, right, it's the carryover, right? This carries. So whatever we have now, if we want to know what we're gonna get next year, you multiply by 1.032, and then you add 600. Okay, and then you can keep going forever and ever as. Okay. So that's it for part C. Just wanted a formula. Okay. Now, being able to write out a formula like this isn't as important as understanding the recursive process. This right here, what we did, is much more important than being able to do this. Okay. All right. Let's take a look at part D. Okay, so for part D, it's asking, how would your answers to part A, B, and C change if the savings account was only paying simple annual interest? Okay, at the equivalent rate. Okay, well, the equivalent rate would still be the same rate, right? The rate wouldn't change. It would still be 3.2%. But how would it be different if it was paying annual interest, simple annual interest? Okay, well, let's go back to what simple annual interest was all about. Okay, I believe that was investigation 1. All right. Now, with annual interest, here is the problem with annual interest. Annual interest only takes into account what you earned in interest the first time. Okay, so for example, if it was annual interest, right, in this case, right, so let's say that this annual interest was let's go back. Okay, so with part D, we're considering simple interest now. And the interest is 3.2%. Right, it's still an annual yield of 3.2%, but now it's simple instead of compound. Okay. So here's what's going to happen with simple interest. Simple interest is going to create something a little bit different because it's only going to consider the first year, like whatever the initial amount is. Simple interest never considers how much money you have in the second year. It only keeps track of, well, this is how much you started with, so this is the amount of interest you're going to get on that amount forever. Okay, so it's always a constant amount that gets added to it. Okay, it's not this recursive process where we get to take the amount that's at the end of the first year to then start with that and earn interest on that. Okay, that's the benefit of compound interest, but simple interest doesn't do that. So for example, right, let's say that, right, again, August 1st, 2000, the family invests $400 into an account. Okay. The next year, right? What happens? Well, we take August 1st now of 2001. Well, that $400, she's going to earn some interest on that. Okay. How much interest does she earn? Well, we know that the 400 times the 0.32 is going to give us $12.80. Okay. So she earns that amount of interest, right? That amount of interest goes back into the account, right? So it's the $12.80 plus the 400. So you get the $412.80. Okay. So still, so far, everything is basically the same as what we had in the compound interest scenario, right? Okay. The parents still add the $600. So you're looking at the $1,012.80. Okay. All right. Now here's where it starts to change. Year 2 now, right? Because this was year 1. Now for year 2. Here's where simple interest falls short. Simple interest will continue to give you the same amount of interest that you got on the original amount that was invested, which means that they're only going to give you interest on the 400. They're not going to give you interest on this new balance. Okay? If it was compound interest, then you could take $1,012, move it up into year 2. Then you can multiply by the interest rate. You would know how much interest you earned. But because you're working with simple interest, this is where simple interest will limit you. It'll let you only earn interest on the initial balance. Okay, or the initial, sorry, not balance, but the initial investment. So that means you're only earning the same amount of interest as year 1, that same amount of interest on year 2. Okay, so here's what happens. For year 2, okay, this is what you start with. You have the $10,012.80, but you're only going to be able to add to that the interest that you earn from the original investment, which was the $400. Okay, see the difference now? You're not able to multiply the $1,012 times the 0.032. You only get to add it to whatever interest is going to be earned by the original investment of 400. Okay, so here you have to end up getting stuck with only earning $12.80 every year, right? See how you've already lost money? Because in year 2, by the compound, you would have earned $32.41. But instead, in year 2, using simple interest, you're only able to earn the same thing that you earned the first year, the $12.80. Okay, so then in reality now, at the end of year 2, here's what you're going to have in the account. You're only going to be able to have $1,000.25 with 60. $1,000, $1,025 with 60 cents. And then same thing happens in year 3, right? So now in year 3, okay, how much is in the account? It's $10,025 with 60 cents. But the amount of interest you get to add into the account only is determined by what your initial investment was, which was $400 way back. Okay, so you're stuck earning only $12.80 every year for the next X amount of years. Okay, so now year 3, add another $12.80, $1,038 with 40 cents. Okay, so you see the downside of having simple interest, right? Look at the year 3. If you go with simple interest, you end up at $1,038 versus at the end of year 3 compound, you could have had $2,200, $2,297 with 86 cents. Okay, and that's where simple interest falls short. Okay, so you're only earning $12.80. Okay, and that's where simple interest will limit you. Okay, does that make sense? That's a really important piece there, because investing in simple interest versus investing in compound interest, you can see the benefit of compound, right? Because it allows you to take whatever you've now earned, right? Compound interest would have allowed you to multiply your percentage times this new balance. But simple interest keeps you limited to whatever you initially invested, right? So if you don't invest much at the beginning, you're only going to be able to earn that small amount of interest every year. Okay. All right. Any questions for me? Does that make sense? How do we feel about that? Thumbs up, thumbs down. Still sleepy. Good to go. Okay. All right. So I'm going to go ahead and stop it here. I am going to assign a little bit of homework just to make sure that the things that we've learned from before don't get too hazy, right? I don't want you guys to forget, especially because we're extending this like much longer than we usually would. Okay, so on page 287, right, the applications, I just want you guys to work through a couple. Okay, so I'm just gonna assign let me see here. I'm gonna assign number 1 and number 2. Okay, number 1 has 2 parts, number 2 has 2 parts, so really it's like four questions really. Okay, so please go ahead and take care of this, and then we'll look over these questions on Thursday. All right, so we'll take a look at them because they are just like a little bit of review. Some of them review simple interest, some of them review compound interest. Okay, so go ahead and work on those for me, and then we'll take a look at them on Thursday. Okay. All right, guys. So that's pretty much it for today. Let me know if you need anything, if you're having a hard time with anything, if you need a Zoom session for Alex, like if there's something on Alex that you're not understanding, send me a message on Remind, send me a message on Schoology. We can try to set up like a little informal, just like office hour. I don't have like any formal office hours because I'm available basically whenever. And I know you guys have other classes and some of those classes make you log on, so I don't want to put another like set of burden on you, but we can take care of Alex problems a little bit earlier. So like if anyone needs to do Alex, we can do it like maybe 8:30 and then we start our class at 9. But basically just let me know if you need any help with anything just to kind of get you by and relieve the stress. Let me know. We can Zoom, and then I can still share my tablet over Zoom so I can work out problems with you. Okay? So I'm here for whatever you guys might need. Let's just try to finish out the week, and then spring break comes, and then you guys can relax a little bit. Okay? All right. Well, take care, and I'll see you guys on Thursday, or if you need any help, then just let me know. Shoot me a message. Okay? All right, guys. Have a good day. I'm going to go ahead and sign off now.